thank you everyone for joining, and thanks for having me at your user group. Wish I could be there in person next time, hopefully. And so this is a tour of the modern Java platform. So we'll be talking about all sorts of things, that not just the language, not just Java language, but kind of all sorts of things around Java and the Java platform. So before we dive into some code, we're going to be going through a lot of code today, but I want to talk about what I think modern actually means. It's a term that I think is a little bit relative. So I think modern is when something makes it easier to deal with increased complexity. So if we're using a new programming language or a new tool or whatever it may be that is making it easier to deal with this growing complexity that we have as we build more complex applications, more complex systems, I think that that's what's modern. And modern can be a spectrum. So there's some things we'll look at today that are kind of on the little incremental spectrum of modern, so they're just slight improvements, and then there's things that we're going to look at today that are bigger improvements because they make it a lot easier to deal with a lot more complexity, things like that. And so keep that in mind as we go through and talk about modern and what that means and looks like. So I'm going to first dive into some Java language stuff, and yay, today is Java 17. So now everything that you're going to be seeing here is actually in a production LTS release for Java, and so that's great. You could start using this stuff as soon as your organization allows you to move to Java 17, but it all is now generally available. Okay, so the first thing that I want to look at is records. So records are a new feature in the Java language, and I think it's a really important feature because there was a lot of boilerplate with doing POJOs in Java, and you'd have to usually would generate in some way the constructors and the getters and setters and the toString and the hash code and all that. And now with records, we're able to reduce that all that boilerplate code down into just this simple definition. And it has one of the things that I love in it, which is immutable properties. So these properties that we set in records, we can't mutate them. And I'll talk a little bit about immutability in a little bit. But that's one of the great things. So really nice, concise syntax for our objects that are going to store data. One of the other new features is newer features. So I'm covering kind of the most important features, I think, for modernization from Java 11 up to Java 17. So var is a new syntax which allows us to not have to specify on the left-hand side the type. And so for me, this is a nice way to read code is really, I think, what it's ultimately about. Is we don't have the redundancy of information about types. And so in this case, we can create a new point and we don't have to give it that left-hand side identifier. Okay, so coming back to our record and immutability, we'll see that if I do try to set a property on my record, then it's a final variable, and so it can't be reassigned. And so for me, this is a great thing. I prefer immutability wherever I can. I use it because what it does for me is it makes a much more logical flow of how mutation happens. And if everything that is a mutation has to be a copy instead of overwriting a value, then I can much more easily, my brain can much more easily understand in the flow of an application where the actual changes are being applied, because they're very explicit, and nothing can change values out from underneath me because it's immutable properties. I really prefer immutable. It also works a lot better in concurrent programming, where if you've got multiple threads, they can't stomp on each other and overwrite each other, and you don't have to do synchronized blocks to alleviate potential issues with that kind of stuff. So the record has built into it a nice toString, and so when we run this, we'll see the nice toString there for the record.
Mm-hmm.
So another new language feature is the text blocks. So before in Java, if we were doing multi-line text, we would have to just do concatenation, and it didn't look very nice. And so there's now a new multi-line text blocks with the triple quotation marks that that make it so that we can do multi-line text. So that's exciting. And then one of the other nice things that we get with records is that as they're stored in memory inside of an array, we get a lot less memory usage for records. So there's some optimizations that they do for how this actually gets stored. We're not replicating all of kind of the overhead of an object in memory if we have an array of records. Instead, we just get the data fields repeated, and so much more efficient storage with records as well. So let's run this thing so we can actually see the toString method there for this one. So this is the out of the box toString method for my record. So nice syntax there out of the box for toStringing a record. And then you can see that my fancy text block there below. Okay, so records, definitely one of the I think nice modern features to the Java language, now available in Java 17. Okay, let's go on to the next example here, which is Java has added much better null pointer exception messages. And so if you're working with things that can be null, and we've got an example here where we've got this tree of objects. We've got a me6 that has a thing that has a plumbus, and if our plumbus is null, we've got both of these, and we want to just print those out, but we're accessing the plumbus and some property on plumbus. This is going to throw a null pointer exception. And so let's run this thing so that you can see the nice new error message that we get when we get a null pointer exception. So you'll see I got my null pointer exception, but it's actually telling me now can't read field S. So if we look back here, can't read field S because it.thing.plumbus is null. So much better information there for helping me to understand what was actually null, whereas before it's just like, hey, you got a null pointer exception with not much additional information. Okay, so that's a nice new modern language improvement. Okay, now the next one is what are called sealed, and there's various things that you can make sealed. And so in this case, what I've created is a sealed interface called a robot. And then I can tell it in here where what is allowed to be a class that implements that interface. So this is just one way to use sealed, but it's allowing me to constrain the places that can then implement a given interface or extend a class, stuff like that. And so in this case, I've got my my class vacuum, which implements robot, my snowblower, and my lawnmower. So those are my three things that are allowed. If I were to come in and try to make a new thing that it implements robot, the compiler would be like, hey, you're not permitted to do that because it's sealed and you've not been permitted to do that. And so ultimately what this is kind of moving us towards in the language is something called algebraic data types. Algebraic data types have two primary ways of doing algebraic data types. There's product types, and a product type is kind of like the record. And so for all intents and purposes, the record is our ADT product type. And then the sealed allows us to create the other type of ADT, which is a sum type. And a sum type is kind of like an enum. What it is it allows us to say that this thing can either be a vacuum or a snowblower or a lawnmower. And the way that we do that is we say that it's a robot, but we know that it can only be one of these three types. So we constrain the types that something can be, and that's the sum type. So if we have a method where we're going to take a robot, then we can now do some fancier stuff because we've constrained the possible places where that can, the possible types that can be. So the old way of doing this is that we would say, all right, if robot is an instance of vacuum, then we do our cast on robot, and then we can call a method. So for our vacuum, it has a suck method. So, so that's what our vacuum can do. So that's the old way. So there's a new way that we can do this where we say, all right, and this is under the banner of pattern matching. It doesn't look a whole lot like the pattern matching that I've used in other languages. So I would maybe call it like a type predicate cast or something else. But what we can ultimately do is we can say, all right, robot, if you're an instance of vacuum, then assign that to a value, a variable v, and that v is a vacuum. So if we look at v, it's already been casted to be a vacuum. And so that's cool. Like we have a nicer syntax to do this. And let's see if it's going to give me any issues with, yeah. So in it's also going to tell us, hey, you know, there's no way that robot can be a string. It's actually a robot, not a string, and so that's not valid. But where this gets more interesting is in a language feature that is not yet released, which is doing a switch statement on robot and then allowing you to specify the cases for robot. And in this case, because it's a sealed, robot is sealed, we can now get exhaustive pattern matching. So I have this commented out because it's an experimental language feature, which we could go enable, but I didn't. And so in this case, what I can do is I can say, all right, if it's a vacuum, you know, do whatever. It's a lawnmower, do whatever. If it's a snowblower, do whatever. But because it's sealed, if I were to remove one of those case statements, then it's actually going to be a compile error because the compiler knows what are the three things that are permitted to be possible types that can be used as a robot. And the compiler then will tell me, hey, you haven't done an exhaustive pattern match, and so it'll give you a compile error. So that's where the sum types and the sealed stuff really gets interesting, I think, is with the pattern matching, the switch statement there. So okay, so those are some very interesting to me modern language, Java language features that I wanted to highlight. And we're gonna go into a whole nother direction in a few minutes, but I wanna stop there and see if there's any questions about any of these features or any comments on any of that. Okay, all right. And feel free to post in the chat, or I think you can go off mute as well. And yeah, let me know if you have any questions or anything. All right, so let's recap these features. We've got records, type inference, text blocks. We've got sealed, which are basically sum types, pattern matching, and then we've got the useful null messages as well. Oh, and then I actually forgot to show it, but there is now some nicer ways to construct collections. So when I do the set of, that's just a nicer way to construct a set. There's nice methods for creating all the different collection types. So that's another nice new language feature as well. So those are the features that I wanted to highlight. Certainly there's been a lot of other features since Java 11 as well, but those are the ones that stuck out to me as being some of the more modern language features. There's also some nice modern new tooling in the JDK that I'm not going to go into details on, other than to say, hey, modules, they're a nice way to modularize an application, similar to OSGI, which you might be familiar with. Maybe you're already using modules or familiar with them. JShell is the new REPL for Java, which is now just built into Java, which is nice to have. And then there's JPackage, which is a tool to package Java applications up into executables that contain the JVM, so you can double click, run them, that sort of thing. And so that's a nice new JDK tooling piece as well. Okay, let me show you where that GitHub repo is. So that's up on my GitHub and modern-java-spring one. So last week I gave this presentation at Spring One with Bruce Eckel, and so that's why it's called Modern Java Spring One. Okay, so that's the kind of language feature side of things that I wanted to go into. Now I'm going to switch gears a bit and talk about some of the language features that are outside of the Java language and dive into that. So let's see, to start, let's go check out the application that I'm going to be working with. So I've got this application, it's up and running on the cloud. It's using Postgres on the cloud. It's using a Google Cloud service because I work at Google Cloud. I used Cloud Run to deploy this service, but there we go, running on the cloud, talking to a database. And what I can do is I can come in and add bars and those save into the database. So about as simple of a CRUD application as we can possibly get. But what I want to do is show some of the other modern features of the Java platform by dissecting this application and going through some of the pieces of it. So the first thing that we're going to dive into is I'm going to actually start by running the tests for this application so that we can then go unpack some of the cool things that are underneath the covers here. So when I run my Gradle test, what it's going to do is obviously compile everything. And then in this case, my tests need a actual database. So this is an integration test. And so instead of starting up a database manually or using H2, which can be very error prone, instead what I'm going to do is I'm going to use something called test containers. And with test containers, it'll automatically start up my Postgres database for me, and then it will run an init script on my database, and then my 3-year-old son is pounding on my door. That's the joy of presenting from home. And so it'll start up the Postgres database, and then initialize the schema, and then run my integration tests against that database and pass the connection information for how to connect to that database to my application. Okay, so that all worked. My very simple test passed, and so that's very exciting. Hey Jonah, I'm on a call. Okay, so bear with me 1 second. All right, sorry about that. So test containers are this great way to spin up any service dependencies that I have for my application and be able to connect to them from my Spring Boot application. Okay, so let's actually catch my breath because I just ran up the stairs. So let's go over into the source code where we can actually see this test and how it actually works. So I've got a Spring Boot test, and I'm auto wiring into this a bar repo. Whew, it's running and now I'm all out of breath. Okay, so my bar repo, what it is a reactive CRUD repository. My reactive CRUD repository is, we're going to talk about reactive in a little bit, but this is non-blocking database access with all the convenience methods on this thing. And It is a repository of bar. So bar is a data class. So I'm in Kotlin here, and I've got something like the record, which is a data class called bar. And I tell Spring Boot about the primary key. And then I have a val, which is a long, and the long is nullable. So we put this question mark at the end of that. And so that that question mark says that this property can be null. And so with Kotlin, and I do a lot of Scala as well, we try to, in the type system, convey nullability. And so what this makes me do is, as a developer, I have to deal with the possibility that something could be null. And because something can be null, I hopefully will not get any null pointer exceptions, because those are cases where I haven't dealt with the possibility that something can be null. So that's what that question mark is for. So in the case of a bar that's stored in the database is assigning that primary key. And so it's assigning the primary key, but before the primary key gets assigned, I don't have an ID. And so that's why this particular field is nullable. Okay, so then we've got a name, which is a string. And the string here is non-nullable, so that has to be set. And these are all immutable properties here. So that's my data class, similar in some ways to the record that we saw in Java. Okay, so my reactive CRUD repository has a bar as the object that it's going to be dealing with in the database, and then the primary key is a long. So with Spring, all I have to do is define the interface, and then all of the methods to create bars and update bars and get bars and all that kind of stuff, that all is going to be just available out of the box for me. Okay, so that's my bar repo. Let's go back to the test and see how this actually works. So I've got a test that is going to save a bar into the database. So we call save, we give it a bar. You'll see that the ID of this thing is null. And so, so we're creating the bar, we're saving it. Then what we get back from calling save is a mono. So Spring, I'm using Spring and the Spring Reactor stuff, which is async and non-blocking. And so what I get back is a mono, which is this, it's like a future in other languages. It's something that will in the future have the value, but it's a non-blocking way to interact with usually network resources. And so I call save on my bar, and then I like to use, I'm in Kotlin, and I like to use something called Kotlin coroutines, because Kotlin coroutines are a really nice way to deal with anything that is async, anything that's concurrent, multi-threaded. And so by calling await first on this thing, this is an extension method, which I'll get into in a minute, and it converts this bar, this mono into a coroutine, into something that that Kotlin knows about as being a non-blocking thing. So I call await first because I don't want to continue running the rest of this until I have until this is finished, because the next part of my test is going to be to check that it's there. So I want to make sure that it actually was there. So that's why I call await first. Is it's in a non-blocking async way. It's not going to continue to this next part of this next line 17 until this save is actually completed, or this mono that's underneath the covers is actually completed and saved successfully. Okay, so coroutines are this nice way in Kotlin to do the same thing that monos and fluxes are the stream side of Reactor. So it's a nice way to coroutines are the way to do the monos, and then there's another API called flow, which is a way to do the flux. Okay, so we have the next line here where we're going to go get the bars from the database. So I use that repo I call find all, and then find all, if we look at find all, it returns a flux. So that's a stream oriented thing, but I'm going to just turn that stream into a list. But when I call collect list, that's going to convert it to a mono of list of bar. and then I call await first to then get to my my coroutine, my Kotlin coroutine. So again, non-blocking, but it's not going to go on to this next line until that is come back from the database and completed. So when I say come back from the database, what's actually happening underneath the covers here is this is a non-blocking database driver. It's using R2DBC under the covers, and so the request is going to be sent to the database, but sometimes it takes some time for the database to actually do what it needs to do and respond. And so then while I'm just waiting for the database to respond, it's not going to consume a thread or resources while we're in that wait state. It instead will be able to suspend the execution of this thing. And then when the database does respond and give us our value or say that the save was successful, then it will kind of wake back up and continue execution. We can also do this with just monos by chaining monos and doing mono transformations and stuff. But in this case, I'm in Kotlin. I like to use the coroutines, so I converted the monos to the coroutines. Okay, so then we can run our assertions. Okay, but where did my actual database come from in this case? So remember when I ran this thing, it actually started up a Postgres test container and actually ran my tests against that actual Postgres database. So unlike H2, which is nice because it's all in memory, I'm going to use Postgres here because that's what my production system is using. So I really can alleviate the number of places where things can go wrong because they're different between my production system and my local dev or my integration tests. I really want to try to keep as much parity as I possibly can between those. So that's the nice thing about test containers. Test containers just take the Docker container for, in this case, Postgres, and start it up, get the connection information, and then I hand it to my Spring application. So let's look at how I actually do that. So what I've done is I have this test connection factory, which is based on the Postgres test container. So we're starting up our Postgres test container. We give it the version there. And then I can even give it an init script to initialize my schema. And so that's my Spring component. I tell it to stop on being destroyed. But then we need to actually set up the connection factory so that we know how to connect to this Postgres database that's running in Docker. And so that's where I do a little bit of work here to map the information from my Postgres test container into the connection factory, which is what R2DBC needs to actually connect to that database. And so this class, this whole thing that I have set up here, I've just got it in the test scope. And so this is only going to be used when I'm in my integration test. And then I've also set up my local development so that it uses this test scope stuff as well. So that's how it actually then sets up the database. There's a couple other ways to connect to and start up test containers and all that. Okay, so that is the test container piece of that, and we saw that all working. Okay, so you've seen the test run, you've seen it do the test container, and that's all great. Let's move on to the actual application that you saw. So you'll remember that we've got our application up and running here, and of course I can run it locally, whatever. But if we go to back to our main.kt, our main Kotlin file, we can see a few other things that are interesting. We've got our get mapping, which is using a Kotlin library to construct our HTML page. So a nice type safe way to create HTML if you're into that. But the more interesting parts, more relevant parts that I think are where we get to nice modern pieces of this is I have my get bars function, which is a get mapping for /bars. And this function returns a list of bar, but you'll see that it's a suspend function. So the suspend is a keyword in Kotlin, which hooks us into coroutines. So what it says is that calling this function is going to be non-blocking async and using coroutines. And so that's how we convey to Kotlin, and then the Kotlin does all the magic underneath the covers to kind of unravel this into something that that can be non-blocking and runs on fibers and all that. So okay, so now our get bars method, what it does is it goes to our bar repo, find all, and then the collect list, and then turn it into the coroutine. And so that is a coroutine, and so that we tell the controller function, we need to tell it that it is a suspend fun. If we take that out, then we get an error. It's like, hey, you're not in a coroutine context. You need to be in a suspend fun to be able to call another suspend fun. And so that has to be a suspend fun. But here's the really cool thing is that now we are async and non-blocking or reactive all the way through the request chain. So a request is going to come into this controller. It's going to go fire off the request to the database to go find all the bars. But in the time that we're just waiting for that response to come back, there's no threads allocated to the call to the database or to the actual HTTP call that is being made to this. So no resources being used for this thing while we're just in that wait state. And then as soon as we get the bars back from the database, then it then reactivates all that stuff and is able to send the HTTP response, which is our serialized list of bar, back out to the requester. And then we do something very similar with our post mapping to create our bars. So we've got our add bar, we parse our body, and then we're able to save our bar to the database. In this case, we take advantage of the explicit nullability support here, where save could be null if the save was unsuccessful. And so what I'm doing is I'm not just saying await first, because await first would throw a null pointer exception when I tried to use it if the save was unsuccessful. So instead, what I do is I call await first or null, and then I add this little question mark here, which now the question mark on something allows me to traverse into that thing and use it when it's not null. And so I'm saying, all right, when it's not null, return a no content response. But then I use this called the Elvis operator to specify when that was null. And in that case, I'm going to return an internal server error. Okay. So that's async non-blocking all the way down through my application from requests. So Spring Boot has great support for the suspend functions in Kotlin, and then it has these extension methods. So when I called collect list as an example on this, it returned a mono, but I wanted to convert that mono into a coroutine. And so you'll see that I'm just doing dot await first on that mono. Well, await first is not a function that is on mono. So this is a nice new modern language feature that Kotlin did a great job adding, is what's called extension methods. So extension methods allow something to add functions to existing classes. So in this case, the await first extension function is adding functionality to the mono that gets returned from collect list. So and this is used all over the place in Kotlin. It's used to add functionality to the Java collections APIs and all over the place. And the way that this is actually specified, the really cool thing about extension functions is that they are imported. And so that import is what actually brings into my context the ability to have this new method on something. So we can go in and look at this await first. You'll see that it is anything that is a publisher, which includes mono, and adds on this await first method. So extension functions, definitely a nice new modern language feature that allow us to do it's sometimes maybe called like ad hoc polymorphism. It's a way to change the behavior of things in an ad hoc way instead of the typical inheritance based way. So I use this feature all the time when I'm writing in Kotlin, and now Scala 3 also has similar functionality for extension functions as Kotlin. So okay, so that is coroutines and the reactive bits of this application. And let's see, nullability, the explicit nullability. Let's see if there's anything. Immutable data classes we saw with the data class similar to records. And yeah, so lots of great kind of modern language stuff here in Kotlin. I've been using Kotlin for a couple of years now, and really enjoy a lot of the modern language features that they've put into the language. So lots of good stuff to learn there. Okay, let's go on now to actually, let me stop there and see if there are any questions about that before we go on to the next section of this. All right, well, let's continue on. Okay, so for the next part of this, I want to talk about containerization. And containerization is allowing us to package up our applications into essentially zip files and then have those things be portable across to different platforms. So you can run these locally in Docker, you can run them in Kubernetes, you can run them on other container services like the Cloud Run service that I showed before. And so I want to talk for just a little bit about the containerization methods that we can use to containerize applications. So I've got my Spring Boot application here, and let me move this menu out of the way. Let's just put it there for now. Okay, so I can see my command line. So there is now built-in support in Spring Boot to containerize an application. So I can run in Gradle, it's boot build image, and it's a different name in Maven, but I can run this task. And what it's going to do is it's going to take my application, it's going to compile it, it's going to assemble a Docker container that's going to have it's going to have the JVM in this case, it's going to have the dependencies of my application, it's going to have my compiled classes, it's going to have all that stuff in the Docker in the container image, so that this thing can then run on any of those places that I mentioned. So I'm not going to run the task right now because it takes a minute to run. But what I want to do is actually show you what the Docker container image actually looks like. So this is my container image. I started on my local Docker daemon under Kotlin-bars-jvm. And let's go pull this up. Okay, so this is just using the default way that this got built. And the way that this got built in Spring Boot with its out-of-the-box containerization support was using a technology called build packs. And build packs, they are something that originated at Heroku, and Pivotal created build packs, and then Heroku and Pivotal came together and created the cloud native build packs under the Cloud Native Computing Foundation. And build packs are just a standard way to transform source code into containers. And so this is the container that was created when I ran this build image. And we can look through and see what all is in this container image with this tool called Dive. So I've got this base layer, which is like the base operating system, probably some like Ubuntu or Debian-based system, and then I've got layers for other kind of operating system pieces. You can come over here and see what's actually changing as we go through the different layers. The layers, if you're not familiar with them in the world of Docker, what they allow us to do is have better cacheability. So I've got all these different layers, and each layer is a additive piece into the container image that ends up being used when we run it. And so if I were to, let's say, just change my source code, then all of the layers underneath my class files are not going to have to be reloaded by a system or re-downloaded. They instead will, only the one that has my class files in it will actually be the one that gets downloaded, and all the others will be able to be cached. And so there's great cacheability in the way that Docker has set up its layering. Okay, so I'm on a layer that is 144 megabytes. I'm pretty sure that that's the JVM layer for this one. And then we can keep walking down. Probably this 37 meg layer is my jar file dependencies, and we've got more and more layers. So ultimately, one of these layers is probably like my compiled class files, which in this case, there isn't a whole lot. So it's probably one of these smaller layers. But we can see how build packs were able to just create this nice layered Docker image for me with everything that is needed to run in this. And I can go in and actually start up this app, this container here based on the Docker. So I'm going to run the Docker command to start this up. In this case, I'm running it in production mode, so I have to give it the information for how to connect to my Postgres database through environment variables. But let's go start up my Kotlin bars JVM container. We'll see that sure enough, Docker is able to run this thing, and it started in about 3 seconds. So and should work. Just let's go give it actually a try and see how it does. So let's go to localhost 8080, and we should be able to store our bars in the database. So great, it's working. So that was my containerized, now portable, can run this on on Kubernetes or wherever you want to run your containers. Okay, now take note how long it took for this to start up with the JVM was about 3 seconds, a little over 3 seconds, because we're going to compare that in a minute to another way of doing things. So let me see, it looks like maybe there's, looking to see if there's any questions. Doesn't look like there are, but feel free to put those in the chat as I go. Okay, so I've got my my application. I've containerized it with that boot build image, and that's all great. But there is places where you want your application to maybe start up faster than 3.2 seconds. This is a very basic application, took 3 seconds. Large applications can take quite a bit longer to start up. And if you're in a serverless or dynamic scaling environment, and this is something that is in a user request path, like a user just hit checkout on your cart, you don't want them to get what's called a cold start, where this request comes in and a new instance needs to be spun up, and it takes many seconds for that to happen. So the user's just sitting there waiting, and so that's a bad experience. And so there's different techniques for dealing with cold starts, but one of the ways that is a very modern, exciting way to deal with this problem is using something called GraalVM native image. Spring Boot has added support for producing GraalVM native images using they've got an umbrella called Spring Native, which is the way to use GraalVM native image. So GraalVM native image, what it's doing is we run it as part of our tool chain. So we compile into our classes, and then we run GraalVM native image on our class files, and that is going to then ahead of time compile our application from something that runs on the JVM instead down into a native executable that no longer uses the JVM. And this gives us much faster startup time, gives us much better memory, doesn't use as much memory. There's a lot of optimizations that can be done when we do this ahead of time compilation on an application. So the Spring folks have made it really easy to take advantage of GraalVM native image. And the way that we do that is we give some parameters to the build packs. So when the build packs, those cloud native build packs, when they go run and take our source code and turn it into a container image, we're going to tell it to, hey, we want to create a native image and not the usual JVM image. And then we also tell it to use this tiny builder, and so we tell it BP native image to 1 true, and then we can pass any arguments like ignore the Spring SPEL, was it Spring expression language or something like that. Don't put that support in, and other things. So we give it some configuration, but then the way that we do this is we run that same command, that boot build image. So this menu keeps getting in my way of my command line. Let's go see if we run this build image command. Same exact command, but at this time it's going to use GraalVM native image when it creates the container image. And that takes a bit of time. So there is a trade-off to ahead of time compilation, because when I do local development, I am on the JVM. It's the way to get the fastest iteration loop for local development. But what I do now with almost all of my production applications is in my CI/CD process, I create my final image, my final Docker image, with using Spring Native, if I'm using Spring Native, and GraalVM native image, and to create that ahead of time compiled binary. And I have some production applications that are like 7 meg. The total size for the container image is 7 megs for everything. And this is a JVM application, but it has been ahead of time compiled with native image. So, and I also mentioned that these applications, let's go actually look at the one that, let's go dive into the one that was created with the native image stuff. So we can see that this is a much smaller container image. I've got a base operating system of like 17 megs, and then 115 megs for my ahead of time compiled application. So that's pretty large. Like there's a lot of pieces in there. You know, I've got Spring and all its dependencies. I've got, you know, a bunch of JVM pieces in there. So there's, you know, that's a fairly large native application. But I have in this case, Spring has a lot of overhead. In the cases where I've used Scala in places that don't have as much reflection and not a large dependency graph, that's where I've been able to get this down into like 7 megs. But this one still a lot better than, if you remember from the previous image, there was the operating system layer was a lot larger, the JVM layer was a lot larger. So I was able to get the size of this container image down quite a bit by using that native image tool. Okay, let's run that one so you can see. Let's go to this, and I'm going to do Docker run. In this case, it's using the container image that we just looked at, the one that has the GraalVM native image ahead of time compiled version of this application. So let's start up that one, and you'll see that the startup time for this thing was basically 0.1 seconds instead of the 3 seconds that it was for the JVM one. So the startup time, super fast. That's like 30 times faster or something like that. Uses a lot less memory. So if you're in a serverless environment, or if you're building like CLIs, anything that needs to start up quickly and not use as much memory, then GraalVM native image is really a great way to take advantage of that. So really one of the, I think, most exciting things happening in the Java platform, the modern Java platform ecosystem, is GraalVM native image, and lots of great uses for this. Okay,
You
so
have one
that,
question in the
yes,
chat,
go ahead.
James. You can see in the chat you have one
Cool,
question.
let me pull that up. Okay. Connections to database thread pools and other stuff that are allocated by Spring Boot startup behave differently in native images. So there definitely is other things that take time to start up, like connection pools, and so you're definitely not going to be able with connection pools. There is going to be overhead, certainly, to cold starts and you know, rehydrating any caches, that sort of thing. But we are making a huge huge dent on our startup time by doing ahead of time compilation with GraalVM native image. And so so Spring itself, part of the slowness for the Spring startup time on the JVM actually has a lot to do with the kind of dynamic the class path scanning, the bytecode instrumentation, you know, whatever it's actually doing to kind of wire together the Spring application at startup time. But you can see that whatever is happening in Spring Native with the ahead of time compilation in Spring Native has helped to reduce that, as well as GraalVM not having any of the actual JVM overhead startup time as well. So so what is show us what the actual the actual native image looks like. So so I can't do bash in this particular native image because I don't think that I put it in this container image. But what I can show you is if we dive back into that container image, we can go take a look at so it's in this layer is where the native image application was added, and there we see that here is my application. Now it's just the package name and class name there. So this is the 115 meg file that has everything my application needs to run. And yeah, this definitely is not as good from a layer caching perspective, because we've put our dependencies, we've ahead of time compiled everything for our application, the JVM, the dependencies, and our actual application down into a native executable. So we don't get that nice layering that we get in the case of being on the JVM. So so one of the trade-offs there of using native images is losing that nice Docker layering that we had before. Okay, let me know if that answered your questions or not on those things. And that is just a binary application. You can just / run that thing, which is exactly what's happening when I started up this container. There is, it just ran that binary. Cool. Okay, so let's hop back to a couple slides, recap what we saw, and then we'll see if there's any other questions. So so things that you've seen is in Kotlin, some of the modern language features. You've seen data classes, immutability, explicit null ability, extension functions, and I didn't show it too much, but the DSL stuff with the HTML, the way I was creating the HTML page using a Kotlin DSL was there as well. I didn't go into Scala in this one. I use Scala for a lot of stuff. It has a lot of modern features as well, and I'm actually writing a book on that now. So I really enjoyed Scala and a lot of the modern things it has. But back to kind of the original point of modern. Modern, if there's anything that is helping you to make it easier to deal with increased complexity, that's modern. And maybe that's taking advantage of records in Java. Maybe that's using more immutability. Maybe that's using Kotlin. Maybe that's using Scala. Maybe that's using test containers. There's lots of options for how you modernize your application. And so so yeah, hopefully you can take some steps in any of these directions to help you get more modern. And then test containers, love test containers. I think it's a huge benefit for allowing us to better keep our production and dev and test stuff, service dependencies in sync, so that we alleviate potential bugs from moving across environments. Reactive, be reactive all the way down. What I didn't show in this one is another place that is very typical to be reactive is with an HTTP client. So when you're making a request from one service to another service, you can use HTTP clients and be non-blocking on those. Spring has a great web client that is reactive and non-blocking that you can use. Concurrency, coroutines is a great way to do concurrency. There's also Loom on the horizon for Java, which will, I think, really kind of change fundamentally how we deal with concurrency and reactive. And so there's some exciting stuff on the horizon for concurrency as well. But today we've got coroutines in the world of Kotlin. We've got the reactor stuff in Java. In the world of Scala, I use something called Scala Zio and love it for doing concurrency performance stuff. Containers and build packs, like my recommendation is just use build packs if you're creating containers. They hopefully will work for your use case. If not, that's when I take the escape hatch down to a Docker file. But I always try to start with build packs as the default, because then I don't have to maintain any of the logic that says how we get from source code to a container image. That is outsourced, and the build pack team is responsible for that. You can use the Paketo build packs. You can use the Heroku build packs. Google Cloud has build packs. So many different options for how you actually use build packs. But build packs are a great technology, really great piece of the modern Java ecosystem. And then GraalVM native image, which you saw, which has some really exciting things about startup time and memory usage, and native executables. So, okay, so that's your recap on that particular example. The source code for all of this stuff is up on my GitHub. It's in a repo called Kotlin-bars, and it's on a branch called Spring One. So, so if you want any of that code, check that out. Also, I wrote a blog a while back, let's see, it was 5-6 months ago or something, on the modern Java platform. And there goes into more details on a number of these topics and talks about a few other topics like some developer experience, things that are modern developer experience, ability to have like nice tight iterations as I'm working on an application, and hot reload type of things. And so, so lots of exciting things happening all over the Java platform to help us move forward and tackle more complex problems more easily. So, so okay, that's all I had. Let's open it up for some questions. I got plenty of time to answer any questions you all may have.
I see there is some question in the chat, James.
Ah, cool. Let me open that up. So build packs and Spring Boot, the way that it works is that build packs are this this tool that will then use the build packs, which are the things that actually know how to transform Java or Python or Node or whatever, know how to transform that into the container image. So build packs are that tooling that's there that enables you to do that transform. The relationship to Spring Boot is that when you run the Gradle or Maven tasks to containerize an image with the boot build image task, what that does is that actually uses build packs to do that containerization. Once you get it into a container, then you can run it on Kubernetes, you can run it on Cloud Run, you can run it on Docker, whatever. So that's what the build pack stuff is. Something that allows you not to maintain the Knative or the Kubernetes deployment files to generate pods. So there are a number of tools out there that that will do that piece for you, but that is not part of build packs. Build packs are really just about creating the container image, and then you can apply other tools on top of that to actually kind of manage Kubernetes, to do your deployments and that sort of thing. There's I think probably the most used tool in this space is Terraform, and Terraform is great for doing infrastructure as code and managing your essentially deployment descriptors through something higher level and easier to deal with. So, but a number of other tools out there as well for doing that. Yeah, good question. Okay, what else?
We had one before that one. It related to is it possible to Docker exec? Do you see this question?
Oh yeah, and I did answer that one. That was, I couldn't do
Yeah.
Docker exec on my container image because it
see.
didn't actually have bash in the container image because I was using a very small
Interesting.
container image. But I did show in the dive tool how that executable was stored and how it was a fairly large executable at like 116 megs or something like that. And so I think that's what they were looking for on that Docker exec question.
I think there was one question that we didn't address. That was can you explain again record modifier?
Yeah, good question. So the record modifier, and let me just hop over to my slides. What the record does is it's basically doing all of the work of what you normally would do with a POJO, where you would generate the getters and setters and the constructors and the hash code and the toString. Normally you generate that through tooling or through IntelliJ or whatever. The record is doing all of that work for you, and it is generating the toString, and so it's just a much nicer way to create those POJO things that are going to hold data. Nice things about it is that it's all immutable, and it has, when used in an array, context, it has a much more memory efficient storage mechanism. So, so if you've used data classes in Kotlin or case classes in Scala, very similar to those, but also those JVM improvements for memory storage. So, so that's what the record modifier is doing there.
Like, sorry.
Go ahead. Yeah.
This project is like a Lombok library.
Yeah, exactly. Lombok was doing the same thing as well. So,
thank you.
Yep. And now it's just built into the language with Java 17.
But it's handled like differently. It's not pointers. It's handled on the stack, or like it's the same as a normal class.
It's the same as a normal class. So you knew it just like a normal class. You toString it like a normal class. You can add methods onto it like a normal class. Really, the one of the main differences is in how the memory gets stored underneath the covers from the JVM side of things. So that's one of the huge benefits of using records versus data classes, because data classes in Kotlin and case classes in Scala, they can't do that JVM memory optimization that records are able to do. So I think maybe at some point we'll see data classes and case classes maybe rebuild on top of records to take advantage of that better memory storage. But yeah, so it looks and feels just like a normal class, but has a lot of advantages underneath the covers.
You said something about that it's handled differently when we hold it in an array.
Yep.
So this is like something confusing for me, because like an array, it's always an array of pointers. It's never an array of the class itself. So why?
So I think that, and maybe there are better experts on how the JVM actually stores stuff than I am, but the way that it was explained to me was that that when you have an array of objects, you are storing the object essentially in memory each time, and there is some overhead to storing an object in memory. If you're storing, in this case, like I'm storing multiple points. So I'm kind of replicating some metadata about the actual class in memory each time. And what the record, the way that it stores, is that it just has that kind of metadata about a point once in memory, and then it just has the data fields and not any of the actual overhead of the object as well for each actual instance of that thing. So that was the way that it was explained to me, but maybe there's somebody that's a deeper expert on JVM stuff than I am.
By the way, in the latest Kotlin, you can mark data classes Java record with an annotation.
Oh,
it will
cool.
compile it and use record. Yeah, it's brand new. It's a couple of days ago.
Oh, that's awesome. Very cool.
I see there is one more question in the chat.
Oh, cool. Okay. Test containers. So test containers running Spring Boot test might introduce an overhead, because in real application, all the persistence technologies are required. The whole application should be started. Can we test containers between tests so that the Docker containers won't be created for each test? Yes, absolutely. So one of the really nice things about test containers is that you actually control the life cycle of the test container. And so there's different ways to control the life cycle, but it's up to you how that life cycle happens. So in Spring Boot doesn't yet have like I would say super awesome support for controlling this life cycle yet, but it will get better over time. So what I've done in some of my other applications is, in some of my tests, I want the whole like suite to use one instance of a container and reuse it. And in other parts of the test, I want it to do a new instance every single time. So it really depends on the tests that I'm running, and are they kind of like sequential applications that are dependent on each other or not, or can I run all this stuff in parallel? So there's a lot of different factors, but ultimately the nice thing about test containers is that you control the lifecycle of the container itself. And so it definitely if you're used to using H2, then you are going to have additional overhead than what you're used to. But at some point in an application, you should really be testing an application against the actual database that you're going to use in production. And so that's, there may be a trade-off to that where, yeah, your integration tests are going to take more time because you actually do have to spin up a Postgres database container, but hopefully that's worth it. And as you have controlled the lifecycle of the container, you've done some optimizations around that as well. So one of the other nice things that Test Containers does is that it randomizes the port selection. So you can actually parallelize the execution of tests that are independent and run multiple containers at the same time, since you don't get into port conflicts. And because the container lifecycle is controlled by the tests, you don't have to worry about, like with Docker Compose, it's something external to the tool that is controlling the lifecycle. Whereas with test containers, it's me as the developer test author that is controlling that lifecycle. Quarkus is an alternative to Spring Boot, and it now has built-in support for test containers and has added a lot of this controls into it. And I haven't used that a lot, but it looks pretty nice for how they've also integrated test containers into their local dev experience, which is really nice as well. So it doesn't restart the database when you make code changes and some of those things. So but there's I think some up and coming work that'll make this even better. But already I'm using test containers everywhere I can because it really gives me strong guarantees around consistency as I move across different environments. When I do my local dev and I do my integration tests, I do my integration tests in CI, I do my production, I can be sure that I'm testing against the same service. And that's really nice. Okay, and there was a question actually further back, which was about using the reactive Postgres stuff in production. And so I do have an application that I built a while back that is using the reactive database stuff in production, and have had great experiences with it. No like weird production issues or anything due to that. They definitely are on the much newer side of things, the reactive database drivers, but R2DBC is, I think, pretty stable now and being used in a lot of places. Now, I don't think it's got 100% coverage of the protocol, and so there may be places where you run into issues. But if you're using test containers, you'll know about that before you get to production. So yeah, I'm totally convinced on the reactive database drivers, and you've been using them for a few years and had great experiences.
And James, how do you compare a build pack with Google's Gib, G-I-B
Yep.
plugin tool?
Yeah, I've used Jib quite a bit, and Jib is great. It does a really good job of creating well-layered container images. It has great caching. Like, there's a lot of really great things about Jib, and so Jib is a great option. But the downside of Jib is that it's only for the JVM, so you can only use Jib on Maven and Gradle projects essentially, whereas build packs is much more universal. And then Jib, last time I looked, they didn't yet have support for GraalVM native image, and that's a tool that I'm using a lot more now. And so that was another reason why I gravitated towards build packs. But if Jib works for you, it's great, and definitely would recommend it as a much better option than using Docker files. With Docker files, you just have to deal with too much maintenance and too many potential issues. You have to deal with security on your own. You have to deal with cacheability on your own. Too much stuff that I don't want to deal with. I just want to outsource that to some expert, and Jib is one way to do that. Build packs another. Yeah, and thanks, Ali, for posting my blog post about comparing those options. Cool. What other questions are there?
Do you think that people will keep using Lombok right now?
I think that the new features really will make it so you do not have to as readily reach for Lombok, and I'm excited about that. I think it's nice to just have a lot of that Lombok stuff built into the language now. I was never much of a big Lombok user because I went to Scala and Kotlin, but for those that are using Java with Lombok, I think in Java 17, I don't know if there's any like really compelling reasons to still use Lombok. Yeah, I don't know Lombok well enough to probably answer that. But question about native images. Is there any difference in production maintenance between the regular app and the native one? Taking heap dumps, debugging remotely, bytecode instrumentation for profiling. Yes, definitely there is. So when you move off the JVM, which is what you do when you do GraalVM native image, you do lose a lot of the power of the JVM. So you do get that super fast startup time and all that. But there are tools that just don't work when you have ahead of time compiled an application. And I don't know the extent of that, but the one that I do know can be an issue is when you, the JVM has a great plugin model using agents, and agents are often used for collecting metrics, that sort of thing. And agents do not work with ahead of time compiled applications. And so that's one place where if you need an agent, GraalVM native image today is as far as I know not an option for you. So so there definitely is a trade-off there. I think you can do debugging with a GraalVM native image, but you have to explicitly kind of enable that. And so so that may or may not work in your case, but and may have a performance hit and stuff. But yeah, the GraalVM, you definitely, with ahead of time compilation and going to a native image, you sacrifice a lot of the great things about the JVM by doing that. So so may or may not work for you and what you need. Yeah, great question.
Just a question about the native images. Can I use any library in it, or it's like I need? Let's say I'm using like a client for Kafka, or I don't know what. I need a special client for this, or I can use the normal one.
So the idea of GraalVM native image is you can take any JVM application and ahead of time compile it to a native image. There are some caveats to that. So anything that is dynamic in a JVM application needs to be, you need to tell GraalVM native image about that dynamic stuff. So reflection is dynamic. So you have to tell GraalVM about all the reflection points. JNI is dynamic. It's not something that can, GraalVM needs to know about it. Dynamic proxies, like there's a number of things that GraalVM, it can deal with it, but you have to tell it about it. And so some of the work that Spring Native is doing for you is figuring that stuff out and giving that information to GraalVM for you. And then there's also a config file syntax that is JSON config files where you can specify this information about like reflection points. And so what a lot of Java libraries have done is add that reflection information into the library itself so that you as the user that's running native image on something don't have to go through and figure out all the reflection points that are inside of a library. And so the library ecosystem has generally been adding that metadata into the libraries themselves so that you as the user don't have to think about it. And then the Spring team has been working closely with the GraalVM team to address some of these issues as well. So I would say that yes, generally any JVM library should work with GraalVM native image. The caveat to that is you may have to figure out where the reflection points in a library are so that you can tell GraalVM native image about those.
Okay, thank you.
Yeah, good question. What else?
I think that you convinced people to go and try Java 17.
Awesome. Yeah, it's a huge improvement and lots of exciting things in there. So, and hey, happy release day. Now we can move towards using it in production. All right. Anything else?
I think we can wrap up.
Cool. All right. Well, thank you all for attending. I hope that was useful for you. Hopefully you saw some good modern stuff in the Java platform, and hopefully that helps you be more modern. And and yeah, feel free to let me know if there's any other questions that come up or any way that I can help you. And yeah, next year I'll have to get out there in person. So hopefully, fingers crossed, I'll be able to do that sometime. So thank you all.
Okay,
Great lecture. Thank you.
Thanks a lot, James. You managed to condense those last 5 years quite well into 15 minutes or so. I hope that those ones that produced all those feature ones get offended.
Yep.
But thanks a lot.
Yeah. Awesome.
Thank you very much.
Thanks, James. Thank you very much about the time.
Okay,
It was very, very
and
interesting.
see you all in October event. We'll release hopefully next week or in 2 weeks from now.
You want to do some PR regarding this specific session?
Not yet. Yeah. Thanks. Bye.
Bye.
Bye. Thanks.